all, there was not, I think that a lot of you would have done better if you had looked at the problem. So something happened this week, and that pattern wasn't there the previous week. So I could see that you were doing the problems the previous week. This was a case of not, I started the problems and I couldn't do them anymore. It was, I didn't start the problems at all. So something was different this week, last week for this particular quiz. I'm not sure what. You're welcome to tell me, because it would make me feel better. But the second thing I noticed was there was mistakes that were made from Math 100, a Math 100 level mistake. So one thing you could possibly do is go and learn all of Math 100 again. I don't think that's a good option. So what I'm going to show you is little tricks to immunize yourself against making mistakes that you should have learned from Math 100, but it's irrelevant now because you're here now. So you're going to find ways to fill in gaps without actually relearning all the material from Math 100. So you look at this problem, the first step is to change this into the tangents into sines and cosines, which I think almost everybody did. The second step is to add the fractions and multiply the fractions. And I think because of the rubric, most of you were able to do something with that you knew what had to be done. So you had something like sine squared x, because you multiply numerators here. And there's really a fraction here, right? What's the fraction here? You see just a sine x, but it's really sine over 1, right? So there's really a sine over 1. So sine squared x over cosine x. And on the bottom, we have to get a common denominator. And for the most part, actually, a good number of you did this. You were able to do this, which made me proud. That came from me. That's my class. So now I'm better than a computer. It makes me proud of myself. Okay, so you get sine squared x over cosine x divided by sine x over cosine x plus sine x cosine x over cosine x. So we're there. And then we combine the numerators here, and the denominator stays the same because that's how we add fractions. So I'm going to let you write this before I erase, because I'm trying to work off of the one board where the camera is pointed at. Good? Did I make a mistake? Can you see it? I know it's really light. It looks weird on the webcam too.
So you just put the math step over 1 and then got that.
Right, so right at the step you're asking about? So the idea is to combine these fractions to make the denominators the same. So this denominator has a cosine, this doesn't. So that tells me I'm supposed to multiply top and bottom of this fraction by cosine, so I can match them up.
I get that.
Right. Will?
Why didn't you do that for the top one?
I don't need to because there's no addition here,
Oh, yeah. Okay.
right?
Yeah.
So it's a, thank God, no addition.
Cosine top.
That Catholic thing doesn't work. I also used to do rosaries right before the final, and it didn't seem to help me very much. Okay, then you combine the fractions on the bottom. You get sine x with sine x cosine x over cosine x. And here, at this step, you have ugly, hideous fraction over ugly, hideous fraction. But it doesn't bother you, does it? That you have fraction over fraction. What do you do?
Multiply.
Yep, flip the bottom and multiply, right? So ugly doesn't matter. You can handle the ugly. Just flip the bottom and multiply even as if they were numbers. So does everybody have up to here so I can erase? So at this step right here, where I flipped the denominator and multiplied, that's where some of you were starting to fall apart. And what I suggest as an immunizer, I've made a table. So I have the problem on one page, and on the next page, I have the same problem with a table underneath it. I'm going to show it to you so you can see what I mean. And in that table, you have space to do your step and then run it through with numbers. That's a really quick way to check that whatever you're doing is legal. So if I have numbers, does that work? Flipping the bottom and multiplying? How do you check that? Well, you run through the calculation by hand. You don't have to make it nice. 4/6, don't have to reduce it. Just check on your calculator if you take 1/2 and divide it by 3/4 that you get the same thing. Isn't that the symbols you type on the TI-84? They should be matching. So that I call that an immunizer. Like if you're not comfortable with the algebra, just make sure on the table that you put, this is the number version. You can even put numbers in for each one of these things and just check that whatever move you just made was legal. And almost any random choice of numbers will tell you if it's so. I've done this before. So everybody has gaps. You fill them in as you go. And maybe that's how we really learn. That's a good way to learn. Nothing wrong with it. Does that make sense what I'm doing? I'm just check with numbers if my move was legal. So if you made up a new move, some of you made up new moves. If you made up a new move, it won't work out with numbers. And that's where you know, oh, I made a mistake. Put on your quiz at that moment, I tried this out, it's not working with numbers, I think I'm doing something wrong. That to me means something more than just driving on and making up stuff. Okay? That's a process of learning, that's fine. So put that down. Right, questions so far? No? Got it? Right, so we continue on. The next step is that the cosines drop out, like so. Most of you got that part. This was also a part, there was a problem. Some of you, at this step right here, you slashed one thing, and then you slashed some more things. Some people did this. I can't even bring myself to do it. I'm not allowed to do it. So we'll talk about that in a second. If you do that, then you can check it with numbers. Is that move legal? You have to factor first. You're never allowed to cross when there's a number, a plus sign or a minus sign splitting up two pieces. Right? It's not allowed. So I'm going to come back to that because I don't want a mistake on the clean version. I'll show you how to immunize yourself against that. Now, at this point, you're allowed to slash. Here you are. Because the sin x is a product. It's multiplied. It's not sin x plus something else. Right? So you get sin x over 1 plus cosine x. Sure.
Why did you change because of how on the denominator was supposed to be sin x with sin x cosine x? Did you change?
Because if you, I've used a distributive law. Sin x times 1 gives me sin x. Sin x times cosine x gives me this one. Right? So I'm factoring. When I think of factoring, I think of multiplying. I do cross checks in my mind all the time. You don't realize it because you see me in pre-calculus, but I'm a professional mathematician. That's like a professional weightlifter coming in and pulling up 5-pound weights. They're going to be able to do that, right? So I do it all the time. But I'm going to tell you, I make so many mistakes, it is ridiculous. I have notebooks full of mistakes. So I've learned to immunize myself against making those mistakes. I don't assume that I'm perfect. I assume that I'm full of mistakes. So every step of the way, I just make sure mentally that I can get back to the previous step. So I do a lot of cross-checking back and forth, just to make sure. And the question I think you should ask yourself is, if she's a professional mathematician, if she's doing that, then maybe we should too. And it's a good way. It's a good way to get 100. That's how you get perfect scores. You cross-check back like I just did. Does sine x times this gives me this, sine x times this gives me this. Is it okay? It's okay. So I do it rapidly now, but I know I do it. I definitely do it. Even for your stuff, I do it. I cross-check back. And yet, despite that, you don't see this, but in the PowerPoints I do, there's an eraser. And it's used quite frequently. So I'll go through one of your calculations and have botched it somewhere. But I know when I've made a mistake, and that's the key thing. I can go through it and go, oh, I've made a mistake somewhere. I feel it, I can see it. And part of that is that constant playing with numbers and thinking about what this means if I did the maneuver with numbers. Okay, so we're right here, we're right at the end. This is where we're supposed to end. There's another question. Cassandra, was it from you?
I was the same thing, but just
Okay, so I see a sine x here, I see a sine x here. I think most of you have a feeling that something should happen from here to here, right? So think about it going this way. Most people are good at going this way. So reverse the process. Try a few things and just reverse it. Will?
You have two sine x's on the bottom, and then when you factor them out, why are you only left with one sine x?
Because they canceled. Right here. Can you see it?
No. Even before that, there's
Right
sine
here?
x plus sine x cosine x.
Right.
If you factor them out, wouldn't you take out two sine x's?
No, because multiply it back. This is how you immunize yourself against that. Sine x times 1 gives you this one. Sine x times cosine x gives you this term, right? So it's reverse distributive law. What did you learn first when you learned, did you learn how to use the distributive law first, or did you learn how to factor first? Right, so you're more familiar with that. That's why it feels more right to you to go this way than this way. So use that to your advantage. Take it from this step and reverse it and see if it makes sense. You'll have plenty of time to do that. I give you time. So unlike many pre-calc tests you might have taken in the past, where you have 30 problems to do in 60 minutes, you don't have that here, because I'm against that. So I write letters to the NCTM saying that's not what we want our students to do. I don't believe in that. Okay, any questions on how to do any of these steps? Question? No questions? I gotta wake you up. Good? 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 All right. So there's a step right back here where people made mistakes, and I want to go back to that step. Can I do this? Here's how you can immunize. Same problem, right? I just have 2's there instead of signs there. And I'm just going to do one of these. Does that equal 1/4? Well, the answer is no, because 2 over 6 is not 1/4, it's a third. So you can always check with numbers. And in case you don't like working with fractions, where you've got a huge TI-84 to run these arithmetic calculations. So you don't even have to do these by hand. You can actually take 2 over 2 plus 4 in parentheses and have the calculator crunch it out and see if you get 2 over 6. And see if you get actually 1/4, and you won't. So just check the numbers. So I have a little prop. So I have the problem. If you don't want the prop, it's on the first page. The second page has the prop with the table, so you can put in each step inside a cell, and then right next to it, do a little cross-check with numbers to make sure your maneuvers are equal. So do all these little immunization tricks, and then you'll be able to go forward. That's the way you can learn algebra fast, Math 100 fast. Use it and immunize yourself as you go along. one of my professors told me, you learn algebra and pre-calculus, and you learn pre-calculus and calculus. You really don't learn it in that class, you learn it in the next class. It's true, right? You're really learning Math 100 now. Okay, any questions about any step of the way? Let me see if the step